Hi, this is lesson 1.3, the part A of it for Pre-Cal 11, and we're going to start on page 15 of your workbook. All right, so just remembering from last class that you can multiply the roots of two numbers, and you can, and then it's just like root A times root B equals root of A times B, as long as A and B are greater than or equal to 0. And that works for division as well, as long as your denominator is greater than 0, because of course you can't divide by 0. You can't add or subtract. In this lesson, we're going to do this backwards. We're going to take a radical where we've got a product inside the radical, and we're going to split it into two radicals. That's like the root of A times the root of B. So let's just do an example of this. So root 24 equals the square root of 4 times 6, which means I can say it equals the square root of 4 times the square root of 6. And this is actually, this is really important. This is actually review, but we're going to go over it anyway. So the square root of 18, I can write that as the square root of 9 times 2, which is then the square root of 9 times the square root of 2. Square root of 11 over 4, I can write that as the square root of 11 over the square root of 4. Okay, I do want to just pop up here and point out that these rules only apply if the index is the same for all of them. Okay, the index in this case is 2 because we're there's not one there, but we assume it's given that it's 2 if it's not actually written there, because mathematicians are lazy and we don't bother writing things that are the same all the time. All right, I want you to take a minute, pause the video, and actually work through the rest of this page, and then come back. I'll fill it out too, but I want you to try it yourself, and then come back and see if what you got matches what I had. Okay? All right. Hopefully you got that those three calculations, those numbers are all equivalent, and you can work through and see why that is. So here's some more important vocabulary. Entire radical is when the whole number is under a root symbol or a radical sign, and mixed radicals are when you have part of the number inside and part of the number outside. All right. Okay, let's go to the next page. And there's some definitions for you. Pure or entire radical, like I said, the whole number is underneath the radical sign. It can have any index. And a mixed radical's got some in, some out. Okay. Every mixed radical can be expressed as an entire radical. And the way we do this is to see if the number, the radicand, the number under the sign, has a factor which is a perfect square. So let's do an example here. If I do 108, I can write 108 as 36 times 3. So that's then the square root of 36 times the square root of 3, which is 6 times 3. So 108 is equivalent to 6 root 3, or 6 times root 3. And I encourage you to check that on your calculator. If what you have factored out is not the highest perfect square, then you might need to do it again. And this is really important, that when you're asked to put something into mixed radical form, it's expected that your answer is going to be in simplest form. Just like when we ask you to put something in fraction form, we expect it to be fully reduced into the simplest form, as reduced as you can get it. We want you to take as much out from under the radical sign as you can. These examples are not fantastic because they kind of glossed over how you might need to find these. So I'm just gonna do that for these ones. Well, let me do them use a couple of different strategies here. Okay, so root 50. You're assumed to know these perfect squares. So hopefully you will notice that root 50 equals the square root of 25 times the square root of 2, which means that it's equal to 5 root 2. Okay? Similarly with 45, we should know that 45 is 9 times 5. So that's the square root of 9 times the square root of 5, which means it's 3 root 5. And I guess I took a bit of a shortcut in example A because I didn't write it in everything under the radical, but this is review for you guys, hopefully, so you don't need to do that. For the square root of 320, I'm going to prime factor it so I can show you another strategy for doing this. That's if it's not obvious what's the biggest perfect square to come under there. And that is, like I said, we're just going to do the prime factorization of this. So 320, if I divide that by 2, I get 160, and if I divide that by 2, I get 80, and if I divide that by 2, I get 40, and if I divide that by 2, I get 20, divide that by 2, I get 10, divide that by 2, I get 5. And then there's actually 2 ways I can do this from here. So let me just write all these 2's, write out all the factors again. Okay, so I'm just pretending I've got another copy of the factorization. So one is that I can take the pairs of factors, and I'm going to take one of each of these. So this means that this is going to equal 2 times 2 times 2 times the square root of 5. So that's one, or I could do it as this is going to be the square root of 4 times 4 times 4 times 5, which then becomes, I guess I didn't think this through all the way, sorry. So this is root 4 times root 4 times root 4 times root 5. And since root 4 I know is 2, then that becomes 2 times 2 times 2 times 5, which is 8 root 5. The other way I can do this is I can go, well, here's an 8, 2 times, so I can make my puddles equal. So then I'm going to say that this is equal to the square root of 8 squared times 5, because like that's 8 times 8 times 5. So then this equals the square root of 8 squared times the square root of 5, and the square root of anything squared is the anything. So the square root of 8 squared is 8, and I still get 8 root 5. Okay. And some more examples. Okay. So we're going to convert these to mixed radicals in simplest form. So I'm going to get you to pause because I want you to try these ones on your own, and I will, I'll do them, and then you can come back and check your answers. Okay. All right, I have done example A. I prime factorized it, and then I saw that there's a 4. Why does this thing not? There's a 4 and a 4 and a 4 and a 3, so I wrote that up, and then I simplified it, and I got 16 root 3. I just wanted to do this example live. This one, I noticed that that's going to be 16 times 10, and 16 is a perfect square. So this is going to be 3 over 4 times root 16 root 10. So that's 3 over 4 times 4 times root 10, and then those 4's cancel out, and I end up with 3 times the square root of 10. And I should be checking this on my calculator because 3 root 10 should equal 3/4 times root 160. So if I calculate one and then I subtract the other, I should get 0, right? So I would strongly encourage you to make a habit of checking those if you have a calculator that does that. Okay. Yeah. All right. So let's do C. So my rule says that the square root of 7 over 9 equals the square root of 7 divided by the square root of 9. Okay. One of my cats is trying to rub her face on my pen, so that's not helping me write neatly. Root 7 over 3 is the answer to that one. Okay. All right. That's as far as I'm going to go in this video. you should go and do questions 1 to 5 and then find part B of this lesson. Bye.